Descriptive Statistics Part 2, starting with 7E, Frequency Distribution Tables. So the goal of this will be to add more columns to the tables we've already been doing and use it to analyze and also to compare the tables to a cumulative frequency graph. Before we do this, we need to start with some definitions. Let's start with cumulative frequency. It's the accumulation or sum of the frequencies we have. So if you were to go back to the rad example up here, we had 10 here. The cumulative frequency, we would then add this 10 to this 15 and have 25. And then we'd add 25 to 12 and have 37, so on. That's a cumulative frequency. The relative frequency, and we talked about this before, is the frequency of an event expressed as a fraction. So right here we have 10. The relative frequency would be 10 out of 30, or 0.33, a third. Okay, and then the cumulative relative frequency would be adding up all of these percents, and I will show you what I mean by this example. So right now, the data we have is a list of still rods in meters as produced by a machine. Okay, here are the rod lengths: 0.65, 1.25, 1.4. It's really kind of discrete data because the machine just does specific length rods. And they counted up. So the machine produced one rod of length 0.65. Okay, so a cumulative frequency of that would be 1. And a relative frequency of that then would be 1 divided by 50, or 0.02, because there are 50 rods total. Okay, and the cumulative relative frequency would be 0.02. I'm going to make this a lot bigger so there's lots of room. Okay, for the 1.25, we'll put that there. Okay, there are 2, so the cumulative frequency would be 1 plus this 2, or 3, which would be 3 out of 50. Oops, the relative frequency would not be 3 out of 50. The relative frequency would be 2 out of 50, or 0.04. The cumulative frequency would be the 0.4 plus 0.2, or 0.06. Okay, so for the 1.4, we had 2, so the cumulative frequency would be 3 plus this 2, or 5, and let's just finish it. 5 plus 1 is 6, 6 plus 3 is 8. Oops, I lied, 6 plus 3 is 9, obviously. And goes from there. And then we could write in the relative frequencies, so this would be 5 out of 50. Nope, again, I keep looking at the wrong column, so you have to be very careful. We're talking about just relative, we're looking at this number. So again, it's 2 out of 50, or 0.04. This would be 1 out of 50, or 0.02. And then 3 out of 50, 0.06. Okay? And then the cumulative relative frequency is adding them up. So 0.06 to 0.04 is 0.10 plus this, 0.12 plus this, 0.18. Okay. So that is how you make we have the frequency table, but we have added a cumulative frequency, relative frequency, and a cumulative relative frequency chart. Notice that this is going to add up to all 50. Okay, and if you were to add up this, it would add to 100, or 100% of the data, and then this ends at 100% of the data. So we can use this chart to answer some questions. Okay, what percentage of rods had a length of less than 2.5 or less? And I'm going to go ahead and remove these highlights. Okay, so 2.5 is right here. So we know that 11 rods were at 2.5 or less because it added them up. Okay, 1 plus 2 plus 2 plus 1 plus 3. So 11, and that percentage is 0.22. Oh, I lied. That's or less. Okay, what percentage of rods had a length of 2.5? Okay, that is the 0.04, or 4%. Okay, what percentage of rods had a length of 2.5 or less? That's when you go over here and it adds up all of these different percents, or does it from the 11 out of 50, and that's going to be 0.22, or 22%. Okay, and then it says what percentage of rods had a length of at least 2.5? Well, that's from here up. Okay, so you could do a couple of things. You could add up 0.04 plus 0.06 plus 0.06 plus 0.1 plus all of these, or you could do that we have 100% minus this 18% right here, and that'll give us this remaining amount that we're looking for. And so if we do that, we have 82% or bigger, which makes sense because 22% were smaller, 82% were bigger, and those don't add all the way up to 100 because we counted the 0.04 twice. Okay, so here they've now grouped it. So instead of giving a spot for every single rod length, which was kind of silly because sometimes we had 1 or 2 or 2 or 1, they've grouped the rods. And really what they've done is this is 0 up to, but not including 1 meter. Okay, this is 1 up to, but not including 2 meters. And instead they cut it off at 0.99 everywhere. So between right here and right here, there's a 0.01 space, which is fine because we don't have any rods that fall in there, but usually you won't see that. Usually you'll see them do, like I said before, 0 to 1, 1 to 2, okay, which means this one is not included here, or they'll just do 0 dash, 1 dash, 2 dash, and leave this off, okay? But because this data did just go, didn't have anything between 0.99 and 1, they could do that. So they've done it just again. So what are these things called? Remind yourself, this is called a class or a bin. And in this case, we have a bin length. It's basically 2, but they did it as 0.99. And I think that's kind of silly. I would expect, or not 2, I would expect you to do it as 1. It's approximately 1 meter length. Okay? All right. Now, why they did that was they're trying to show you how to make a cumulative frequency chart or graph, otherwise known as an ogive. Okay? Statisticians in Utah or America would call it an ogive. And so what they did is they did it between 0.99, they did the 0.99s so that they could make a halfway point and make a point between that 0.995. So right in between here is 0.995. And they make these endpoints in between. 1.995. So that they could graph it on a continuous line. And what I mean by that is what they did is they broke it down. Here are bin lengths. A length of 1, 1, 1, 1, 1, 1, or 0.99. And what they claim is that everything over here, okay, is from 0 to 0.99, and everything over here is from 0.9, is from 1 to 1.99. But like I said, there's that space between 0.99 and 1. So they claim that this point right here is 0.995. It's the cutoff. Okay? So any rod lengths between 0 to 0.995 would go between here and here. And anything from above that would here and here. Really, again, and so I'll only show you this because IB does, or AP does, excuse me, IB does this. This is just between 0 up to, but not including 1. Okay, so if IB ever asks you what's the upper endpoint, it's always just halfway between this number and this number. But most statisticians don't fight with that. So once I get rid of that, let me show you what they've done here. Okay, they have just said, well, we have one right here we have 0 rods. From 0 to 0.99 or 0 to 1 we had 1 rod, and then they're adding it up. They're saying, well, from here we had 5, so 1 plus the 5, we now have 6 rods. And so this at 2, it says we have 6 rods that are 2 or less because we had the 1 plus the 5. And then at 3 meters, we have 14 rods that are 3 meters or less. And then we have 17 rods that are 4 meters or less. 31 rods that are 5 meters or less. And all 50 rods are 6 meters or less. Okay, and so this is an ogive. In this case right here, they've done it with the counts. The alternate thing would be to do, I'm actually going to move, well, they did it with the counts. The alternate thing to do would be to do it from 0% up to 100%. Notice I'm doing it in the decimal form. So this would have been 25. That would have been 0.5. And honestly, I find that more useful. They'll do it both ways. Okay. And then you can use this to answer questions without having to look at the chart. What is also nice is you can use it to answer about questions about stuff that's not right in the chart, like how many rods are between or less than 3.5, and you can use this little line that they drew in to help you estimate that. All right, so cumulative, okay, so the question they ask then is how many rods are less than 4 meters? So I'm going to go and look. Go to 4 meters, go up and over, okay, and it looks like there are 17 rods that are 4 meters or less. And then they could take a histogram and turn it into a frequency polygon. And this is really a super IB thing. I've never seen it in any AP stats book. But remember, we could do a histogram. So they did the same thing. They said between 0 and 1 meter, we had 1 rod. Between 1 and 2 meters, we had 5. Notice this is at 6 because it was adding them up, but there were 5. So they just made their frequency polygon. And then, or their histogram. And then a frequency polygon is silly. It just connects the midpoint of each of these boxes with a line. So that if you left, and oftentimes they'll go back down here. Okay, so that if you took off the histogram, you would just have a polygon. Remember, a polygon is a closed figure with no curves that kind of represents how the distribution is. And I think this is fairly useless, but they need you to know it. And to fill in the blank, it says a line graph, which like a histogram gives a good visual approximation of the distribution of shape. The midpoint of each bar is used to represent the whole interval. And again, notice on the histogram that there are labels, 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 and more importantly, no spaces between the bars because the data is continuous, and it goes in order from least to greatest. That's what makes it different from a bar graph where if you did, say, eye color, you could do brown, blue, green and have your chart, or green, blue, brown, and then the pictures would be different, okay, but it doesn't matter the order. We'll stop there and do 7F on the next video.